For decades, the story of how dogs came to be has sounded a lot like a conscious invention. Picture an ancient hunter snatching a wild wolf cub from its den and raising it by the fire. The theory suggests that early humans took those tamed cubs, bred the friendliest ones together, and systematically removed aggressive traits over generations. In this version of history, we engineered the companion. That story is a scientific falsehood. No one mapped out a 10,000-year breeding program. Early nomadic humans lacked the surplus calories to feed hostile animals on a whim, and the archaeological record shows no evidence of intentional breeding during this era. This partnership emerged through an unplanned process of shared survival. It is the result of thousands of years of organic coexistence, rather than human ingenuity. 30,000 years ago, the freezing landscape was populated by deadly wildlife. Immense populations of wolves moved across those exact same plains. These ancient wolves and nomadic humans occupied the same ecological niche as highly intelligent social pack hunters. Both species tracked the same herds across the same territories, making them direct rivals for the same finite calorie sources. They shared nearly identical survival strategies: cooperative groups, complex internal hierarchies, and sophisticated nonverbal communication during hunts. When two apex species share the same territory and targets, they usually clash. However, under specific environmental pressures, high-level competitors can find a mutual advantage in collaboration. The mechanism bringing them together was unintentional: human waste. Nomadic campsites produced a steady supply of discarded bones and leftover meat, illuminated by the firelight. Wolves began trailing human groups to scavenge these scraps. It provided a reliable source of high-density calories, skipping the risk of a high-stakes hunt. Deep inherited caution kept the vast majority of the packs hidden in the darkness. They remained well beyond the edge of the light to avoid confrontation. This created a tense stalemate. The wolves waited for humans to leave the waste behind, but kept enough distance to ensure their own safety. That campfire became a new artificial ecosystem. It offered a massive biological reward to any animal capable of suppressing its fear to cross the threshold into the light. This chart shows temperament in a wild wolf population. Most are highly cautious. On the far edge, a fraction had a genetic variation, higher tolerance for humans. These wolves scavenged more and stayed better fed. They reproduced more often, passing this tolerance to their offspring. Over thousands of years, this unintentional selective pressure replaced inherited fear with social comfort. The population lingering near the fires became a biologically distinct group from the wild packs in the deep woods. Survival at the edge of the camp required an ability to predict human behavior. Wolves that could interpret human gestures avoided conflict and secured more resources, while those that misread the humans were driven away. These cognitive advantages eventually became fixed in their biology. This is why modern dogs possess an innate ability to follow a pointing gesture or read facial expressions, skills that even the most intelligent primates struggle to master. This diagram shows the physiological result of that coevolution. When a human and a dog make eye contact, chemical pathways in both brains activate simultaneously, triggering a mutual release of oxytocin. This is the same hormonal mechanism that regulates the biological bond between a human mother and her newborn child. It ensures a deep physiological attachment. In the ancient world, this connection provided a massive survival edge. Dogs detected approaching predators long before human senses could, and they tracked wounded prey through terrain where humans were blind. They also offered physical protection from the elements. The phrase three-dog night refers to an ancient reality where shared body heat was the only way to survive sub-zero temperatures. This biological synchronization reflects a deep-seated integration of two distinct species' neurological systems. They evolved to be two halves of a single survival unit. We see the weight of this bond in the archaeological record. In some of our oldest intentional burials, human remains are found with their hands resting gently on the bones of a canine. These animals were interred as family members, receiving the same funerary care as the humans themselves. This relationship predates every hallmark of modern history, long before the first farm, the first city, or the first wheel. Every dog alive today is the descendant of that outlier wolf that stepped into the light 30,000 years ago. Through thousands of years in the firelight, two rival predators inadvertently created one another. Our history is inseparable from the animal that chose to stay by the fire.